for any of these operations, this is what is the truth table. Okay, to explain very simply, supposing we have got two values A and B, and when we are performing an AND operation on these variables A and B, this is how the result will come. Okay, so A and supposing A value is 0, B value is 0. So 0 and 0 will become a 0. 0 and 1 will also become a 0. Okay, 0 and any other value for that matter, it will always become a 0. But here, because it is a binary numbers, we are going to use only 0 and 1. Okay, so if it is 1 and 0 is also a 0, only 1 and 1 will become a 1. Okay, just remember this truth table. You can write it down. I'll write it down and give you one that also I put in the group now. So with that, you will be able to easily understand this. Let me just share my screen now. Is the screen visible now?
Yes.
Yeah. So see, these are the truth tables. Okay. So for AND, like I told you, unless both the operands are 1, the outcome will not be a 1. If any one of them is a 0, the output is always a 0 only. Whereas in case of an OR truth table, 0 or 0 is 0. But if either of the operands is a 1, then the outcome will be a 1. That is, 0 or 1 will be a 1. 1 or 0 will be a 1, and 1 or 1 is also a 1. Actually, how do you, I mean, how does this make sense? If you look at logic, like supposing we have, I just say that there is a condition for me to go to office. Okay. What is my condition? If it doesn't rain and there is a bus available, then I'll go to office. Okay. These are my two conditions. First condition is it should not rain. Second condition is there should be a bus available or there should be a vehicle available. Then only I will go to the office. Now, in case of AND operation, if either of these conditions are not met, the outcome will always be negative only. I won't be going to office. Is that clear?
Yes, yes, yeah.
In case of OR, what is happening? Either if this condition is true or that condition is true, outcome will be a true only. Okay. But there is a third kind of an operation. This is called as an XOR operation. So in case of XOR, what will happen is if both the values are same, like if A is 0 and B is 0, the outcome will be 0. Similarly, if A is 1 or B is 1, then also the outcome is negative only, false only, 0. 0 is always a false, 1 is always true. So if either of the operands, that means the operands should not be same. A and B values should not be same. So if either A is 0 and B is 1, output is 1, or A is 1, B is 0, then also the output is 1. The condition in case of XOR is, if we have A and B, the values for A and B should not be the same. So if the values for A and B are not same, then only my output will be 1 or 2. Okay. And in the case of a not table, what will happen? If we simply negate the, if A is 0, then not A will be 1. Okay, just we negate the value. Now, if A is 1, negation or not A will become 0. Okay, so this truth table you can quickly note down in your notebook because so in the case of your bitwise operators also the same truth table we will be using. Okay, so I'll give you 2 minutes, just note down this truth table. Vidya, were you able to understand the truth table? Vidya?
Yes, ma'am. Yes,
Okay.
ma'am. Understand.
Okay. So note down this truth table now.
Yes, ma'am. Doing.
Just let me know when it's finished. Then we'll go to the operations and see how the output is coming.
Done, ma'am.
Yeah. Raviji, you are finished?
Done.
Yeah, I'm good, I'm good.
Yeah. Okay. So where were we? Yeah, we were learning this one. So I was just telling you that supposing value of x is 5 and we are trying to do x is x and 3. Okay. So then what we will do is this is the binary equivalent of 3 and this is the binary equivalent of 5. So these two numbers are taken. Now bit by bit I will do my operation. So according to our AND table, 1 and 1 is what? 1, right? 1 and
Yes.
1 will become 1. 0 and 1 is 0, right? So you will get a 0 bit here. Just put it underneath that so that it will be easy for you to understand. Similarly, 1, if you take this 1 and you take this 0, 1 and 0 is also 0 only, and 0 and 0 is also 0. Okay? So when I convert this 0, 0, 0, 1 into back into a decimal number, the value I will get is a 1. Okay? So now what we will do, we will try to print the value and see what is the output we will get here. X is equal to 5, y equal to 3. So, sorry, no, we are saying x understand 3 and then we are going to print this value let us actually the value you should get is 1. Okay, let's see whether we are getting that 1 or not. Okay, so this way, this is the one when you do the AND operation. Supposing I'm going to do, you can just try both of you. We will take the OR operator now. This value when we do this OR operation, you should get 0, 1, 1, 1, which is nothing but a decimal number of 7. This is what you should get. You can take like this 0, 1, 0, 1, and the 3 is 0, 0, 0, 0, 1, 1. Okay. So when I do an OR operation, bit by bit, the outcome will be, this is what you will get. If you take 1 or 1, it will be a 1. So I'll put 1 here. Similarly, 0 or 1 is also a 1. 1 and 1 or 0 is also a 1. And 0 or 0 is a 0. Okay. So when we convert this binary number into a decimal number, this is actually 7. Okay, this is, let's check whether we get the answer or not. Okay, let's see what will be the answer. We got a 7. Okay, just check whether you got the answer or not.
Yes, ma'am, got it.
Okay, so this is how you can check. This is an XOR. Okay, this operation is called as an XOR operation. Now, this operation here is to we actually take the value and supposing, let me tell you, suppose same value x is equal to 5, 5 is 0, 1, 0, 1. So when we say x supposing we are shifting it by 1 position. Okay, the meaning of this is we are shifting this, whatever is the cells which are there, we are shifting it to the left hand side. Okay, by 1 position. Sorry, to the right side by 1 position. So what will happen now? Here, if you see, this 1 has been moved. This is actually, we call this as a circular shift. Okay, this 1 will just move by 1 place and it will follow. So what will we do? What will we get here when 1 is going off? You will get here 0. This 0 will come as it is. So we'll write the 0 in the last place. Instead of 1, now we have 0. After 0, again we have one more 1. This 1 will come to this place now. After that, there's one more 0. This 0 will come here. Okay. So this is how the shifting of, so this is what is this called? We are shifting the number, this whatever are the bits here, We are shifting them by one position. That is the meaning of this. This is called as a right shift. Okay. If you write like this, then it becomes a left shift. So here what is happening? The numbers are, digits are shifting to the left hand side. Okay. Let us first see the answer for this, then we can go to the. So 0, 0, 1, 1, 0 will be equivalent to 2. 0010 in binary is actually a decimal digit 2. So let's see if we are getting the answer. Okay, so this is how. So I hope you understood. Nothing, just we are shifting the bits to the right hand side. So what is happening? This one will go away now because we have shifted by one position. This one will go away, and in its place, what will come? 0 will come. In 0th place, 1 will come, and in 1 place, 0 will come. Like this, they will just shift by one bit to the right hand side. Is this clear?
Yes, ma'am.
Similarly, we have a left shift also. You can try and see what will the answer you will get when you do the left shift. Okay. So let us take x is equal to 5 and do left shift by one position, and then we print it. Zero one. This time we are moving everything to the right hand side or left hand side. So this red wala 0 will follow. So in its place, first 1 will come. After that you will get 0. After that you will get 1. After that you will this side. And the least significant side, you can just put 0. N number of zeros. It doesn't make any difference as well. So the value you will get is this 0. This is actually equivalent to a decimal number 5. This is what you will get. Okay. So this is called the left shift operator. That this is called as the right shift operator. Okay. So these are all called, actually these are called bitwise operators because they work at a bit level. The number is actually converted into a binary number, and then the operation is done bit by bit. That is why we call them as bitwise operators. So here, what have we done today? So this, just to take a quick recap of what we have done so far, we have looked at arithmetic operators followed by assignment operators. So in case of assignment operators, what are we doing? These operators we are using to assign some values to the variables. So apart from the regular operators, the special operators which we have learned are this ampersand or and operator. This is a pipe sign. This is for OR operation. This is for XOR operation. This is a right shift operator, and this is called as a left shift operator. Okay. So I hope it is clear. You can just practice them at home and see what will be the output. Okay. So now next we will look at comparison operator. Okay. Now what is the use of a comparison operator? It will take two variables, like supposing here, I can compare and see whether these two variables, what is the relationship between these two variables actually. Okay. For example, x value is 5 and y value is 3. Now I want to see whether x is greater than or equal to y or not. Okay. So that there you will use these kind of comparison operators. These are also called as relational operators. Another word for it is relational operators. Let us just try this one. So x is greater than or equal to y. So what is the outcome of this? It should be either true or false. Okay. So x value is 5 and y value is 3. So x is greater than or equal to y is 2. So that is what is the output you will see correct here. Okay. So the use of the comparison operator is to compare two variables. Okay, you can, since it is quite easy, you can apply the other operators and check out. This is called as not equal to. Okay, just like equal to, you have an not equal to operator also. If you want to see if x is equal to y, you should not write x equal to y. Okay, the comparison operator for equal is equal to equal to. You have to write equal to 2 times. Okay, remember this. If you simply say x equal to y, you will get a problem with that. So x is not equal to y, so it is saying false. Supposing I write like this, it will give me a syntax error. See, so this equal to y is not a comparison operator. So if you want to see whether x is equal to y, you have to put two equal to signs. Don't forget that. That is the correct syntax. Okay. Similarly, if I want to see if x is not equal to y, the operator we use is this one. Okay. So I'm sure you have understood. So the rest of the operators you can just check out later on. Anyway, this notebook also, this whatever we are doing session by session, we'll share this notebook also with you. Okay. So can I go to the next kind of operator? Comparison operators are clear now?
Yes, ma'am, it's clear.
Ravi ji? Comfortable, right? Ravi ji, are you there? Okay. Now, the next set of operators, we will call them as logical operators. Okay. So, let's take these two conditions and check out. So, the logical operators are what we have just learned now, and, or, and, not. So, just try this simple program and see what is happening. Okay, x is equal to 5, y is equal to 3, right? So, what are we trying to, there are two conditions which we are checking here. What is the first condition? The first condition is x should be less than 5, okay? And what is the second condition now? X should be less than 10. So, is 5 less than 5? Is the first condition satisfied? 5 is not less than 5, right? So,
Yeah,
this
ma'am.
condition is, first condition is false. What about the second condition? 5 is less than 10. So, the second condition is true. This one is false, but this condition is true. So, according to our truth table, which we have learned earlier, if this is 1 and if this is 0, 0 and 0 is what? 0, na? In the truth table, if you have 0 and 1 or 1 and 0, what is the outcome for that? 0.
1, 0.
No. In and if only if both the conditions are satisfied, you will get a 1. If either
Yes,
of
ma'am.
them is 0, you will get a 0 only. Okay. So for the first print statement, what should be our output? We should get the output as false, na? Because one of the conditions is not
It's
satisfied.
false.
We'll get a false. What about the second statement now? In this, x is less than 5. This first condition is false. Second condition is x should be less than 4. 5 is not less than 4. So both the conditions are false here. Correct?
False.
So the outcome will
Yes.
be a false only.
False.
In the third case, what are we checking? In case of this not operator, what we do is first we will check this condition. Okay? First check the condition, and then if this condition comes to 0, then not of that will be 1, and if the condition comes to 1, not of 1 will be equal to 0. Is that clear? First, what will we do? This bracket part we will evaluate. Okay? We will evaluate this bracket part now. And first we will check whether x is less than 5 or not. Or is this condition correct? 5 is not less than 5. So it is false. Right?
False.
Second is x less than 10. Yes. 5 is less than 10. So the second condition is true. If you have 1, this is 0, and this is a 1. Right? So in our case, 0 and 1 actually comes to what? 0.
Zero.
Correct? 0. So first, this whole thing is evaluated to what? 0 now. Correct? Now when I do a
Yes.
not of it, what will I do? Not of 0 will be just simply negative. I mean, if 0 will become 1, not of 0 is 1, and not of 1 will become 0. So here the answer should be 1 or true. Okay, so let us check our answers. Okay, so false, false, true. Right? So this is how we make use of what are these operators now, which we have seen. These are called logical operators. The three logical operators are and, or, and not. Okay, now we may not have much time. There are 2-3 more operators. I will quickly just go through this Python identity operator and stop there, and then we'll continue after in the next class from here. Okay. From here we will continue on 21st. Now, what is the meaning of the Python identity operator? Okay. What we do here is that this is also used for comparing two. Now we call these variables as objects. Okay, just remember now, these variables are what are objects, and we are going to see whether these two objects or variables are actually the same one and the same or not. Okay, what is the meaning of that? If they are the same only, then they should be stored in the same memory location. Because see, actually yesterday I told you, x is a memory variable, right? It is a variable. So, and this, why we are giving that name x to it? Because we cannot remember the address where that value is stored. We are giving some descriptive name to it, and we are calling it as x. Now it becomes easy for me to remember that variable name. Otherwise, if you want to remember the address of that variable, it becomes very difficult, right? That is the reason why we are giving some name to it. Now here, just to understand this concept, I've taken one. This is called as a, in Python, there is a concept or data type called list. Okay, this is a list. Inside this list, there are two elements. First element is mango, another element is orange. Okay, so X is the name of a list. And there is another list. The name of this list is Y. Okay, Y is also a list. So now when you say x and y are two different variables, because x will be stored in some memory location and y will be stored in some other memory location. Okay, so they are not one and the same, they are actually different, because in one memory box we are storing the value of x, another memory box we are storing the value inside y. Okay, so this identity operator, what it does is, suppose we take like this. Let us take x equal to y also and just compare our values. And the third operation is as x equal to y. Three operations we will be performing and seeing. Okay. So now first is, I'm just asking whether x is equal to z or not. Is x and z are same? No, because x is a different variable, z is a different variable. Inside z, we can take any value. Like supposing I'll create one more, or let us just say we are taking one more variable like this, list like this. I'll put some value in this. Now here in this, I will take some name. Okay, I'm just changing the name. Okay. Now I'm comparing and saying whether x and z are the same object or not. Okay. We are trying to see whether x and z are the same object or not. In the second case, I am trying to see whether x and y are the same object or not. In the third case, I am just writing x equal to y. Let us see what is happening here. Okay. What is it your Python saying? According to Python, x is a different variable, z is a different variable. So, x and z cannot be the same. Okay. That is the meaning of that. Because both x and z are being stored in different memory addresses, memory locations. So they are not the same object. X is a different object, z is a different object. So that is why when I say x is z, it is showing me false. Is this clear? Are you able to understand what?
It's clear, ma'am. Yes, ma'am.
Yeah.
Not
The
last
second
minute and
case,
another 10 minutes.
yeah, we are just winding up. This is the last one.
Yeah.
Okay. Now, in case of the second one, I'm just checking to see if x is y or not. See, in x and y, we are having the same values. X is also having mango, y orange is mango and orange. In y also we have got mango and orange. The elements are same, but x will be stored in a different memory box. Y will be stored in a different memory box. So for this, x is y also will become false now. Okay, I hope it is correct. You are able to understand here. X and y
Yes,
both
ma'am.
are different variables stored in different memory locations. So x cannot be equal. X is not the same as y. No. Look at the third operation. I'm saying I'm now equating x and y. What is the meaning of that? What this means is that whether the values which are there in x are same as the values which are there in y or not. That is the meaning of the third one. So, the values in x are same as the values which are there in y. So, you get a true here. Okay. Supposing now I change it to small n. Or let us change the name of this. Okay. I am taking some other group here. Now, the elements in x and y are not the same, right? Earlier we got this value as true because the elements in both and x and y are the same only. Now this should get us false. Let us execute this and see now. False. Why? Because the elements inside x are different from the elements which are there in y. That is why when you print x equal to y, What is Python doing? It is comparing the elements which are there inside X with the elements which are there in Y. Okay, and the elements are not the same. So that is why it is showing you false. Okay, I hope it is understood.
Yes, ma'am.
Okay. So today we are just going up to these identity operators. So the two, three varieties of operators are there. We will look at them, these two types in tomorrow's class. If there are any doubts, you can ask them now. I hope you are practicing along with me. Okay, are you able to, this program also, you can simply type it on the, in your digital notebook and see whether you are getting this values or not. You can just, whatever
Okay,
I am
ma'am.
doing now, just practice along with me. That will, then your concepts will become much clearer. Okay?
Okay.
Did you do it, Vidya? Were you able to do
Yes,
it?
ma'am.
Yeah.
Yes, ma'am.
Okay. Ravi sir, I couldn't hear your voice. Are you there? Okay, I don't know. So he's not online. I don't know whether. Yeah, please continue. Okay, I'll be on mute. Fine. So hope there are no doubts up to here today.
Yes, ma'am. No doubts.
Okay, fine. So we'll continue tomorrow then.
Okay.
All right. Yeah. Good night.
Okay. Good night, ma'am.
The meeting is ending, so I'll end this.